This problem that has puzzled the modern society since around 1886. How to keep the fizz in your soda. In this in-depth video, we will review the different methods currently available that supposedly can help to keep the gas in our sodas. But to really understand the review, you have to know how the gas gets into the soda and why it goes flat. This will help us to explain why or if these gadgets and methods work, or in some cases, why they can be dangerous. Let's start with the classic question. How does the gas get into our soda? The gas they use is the CO2 or carbon dioxide and is dissolved in their factories using pressure vessels. But there are two tricks they use to make the soda get more CO2 than it normally holds. Well, normally at this stage, it's just water. First, they lower the temperature of the water, making it really cold. Then, they put that water into a high-pressure vessel where they inject the CO2. The CO2 is easier to dissolve at lower temperatures and higher pressure. Then, after that step, they add the flavors, the sugar, and other ingredients, to then finally put it in the bottle or can. So, the soda that comes out of the factory has extra CO2 dissolved in it. This is important.
This process is called forced carbonation and is the simplest and quickest method with the lowest overall cost compared to other alternatives, such as natural carbonation via fermentation. Now that we have enough basic information to quickly understand how the fizz works, let's start with the methods.
The first is simple: soda can lids or soda caps. You already know that forcing the cap on the bottle doesn't work, but maybe you don't know why. The use of these custom caps or lids will only have a standard effect. It's just the same as the caps that are included in the PET bottles. They work the same way. They avoid that the CO2 completely escapes from your soda and keep the gas inside the bottle or can, but out of your soda. For the test, it's almost impossible for me to communicate the taste of the soda, but while I was doing it, I could tell if it was working or not just by looking at the bubbles. You see a side-by-side comparison of how the gas decreases when you first serve it, and then 1 week later, mostly so you can have a reference of what it looks like. Now, it's more difficult in the case of the cans because there's no easy way to close it again, so the can lids are equivalent to the bottle caps. I use that can lid model. You'll see why later. Let's start with the lids. I compared the soda from a fresh open can and a 4 days later version, with and without the lids. I'm sure we all know what the result would be. Also, the lid works as expected, better than no lid at all. But I have to warn you that if you still want to use one of those caps or lids for cosmetic reasons, you have to choose the ones that can withstand pressure, seal tightly, and have a good grip. If you use one of these silicone caps or simple lids, the CO2 pressure will eventually cause them to slip or pop out of the can or bottle. By the way, I'm not recommending any brand. This is an independent video. The conclusion here is simple. With custom soda caps and lids, with good seals and grips, you will get the same results as with the regular standard caps that comes with your PET bottle. In the case of the cans, they could be a good alternative to just leaving the can open, as you saw from the results.
Nice, but that's not what we were looking for. That was the actual reason why you're watching this video. And you may be wondering, why does this happen? Why doesn't it go flat from the factory?
The first reason starts with that little space at the top of the bottle or can that is not filled with soda. It's just air. As you have heard, some gas escapes from the soda, that's why it fizzes. But the gas escape process stops when the pressure of the CO2 in that empty space equals the pressure of the CO2 dissolved in the soda. They reach an equilibrium. That's why it doesn't go flat from the factory. Remember that space is small, and the soda comes with extra CO2 dissolved in it. The state I call equilibrium was explained by William Henry in 1803. He discovered that the amount of a dissolved gas in a liquid is proportional to its partial pressure above the liquid, so the gas in the soda also depends on the pressure of the same gas above the liquid. More pressure, more dissolved gas. That's what they did at the factory. This is known as Henry's Law. So, thank you, Henry. Now, the more we drink, the more that empty space at the top increases, and we need more CO2 to fill that space and reach that equilibrium, and the only CO2 available is in the soda. That's why when you close the bottle after drinking, you'll notice that the bottle will eventually feel a little more pressurized than when you close it right after serving, if it has enough soda, of course. So the key variables here are the pressure and the amount of CO2 available. The second is probably the most famous and at first glance the most plausible, the soda pump caps. This is the one that inspired this video. They come in different presentations, the tube, the pump, or a combination of both. There is also a version for soda cans. This claims to work by pumping air into the bottle or can until you feel it is pressurized again. So we should be able to cover up the gas that escaped from the bottle, and since it's sealed now, the CO2 won't escape from the soda, right? Well, no. Apart from this cool pop, the soda will go flat anyway. I tested it with large bottles and small bottles, and the result was the same. You are now looking at a side-by-side comparison on the screen that pretty much speaks for itself. And believe me, I repeated the experiment 2 times. Here is my first footage, when this video was supposed to be just a review of the pump in 2021. So, what's wrong? Like I said, it pumps air into the bottle, not CO2.
Yeah, but air is a mixture of gases like nitrogen, oxygen, argon, and carbon dioxide.
Yes, but the air contains only 0.04% CO2. Remember Henry's law? It takes more CO2 than that to reach equilibrium.
But this other gases doesn't put pressure on soda. When I squeeze the bottle, it feels pressurized.
Yes, it does really feel pressurized. It's full of air. And John Dalton in the 18th century discovered that a good approximation is that each gas independently contributes to the total pressure in a closed system, in this case the closed bottle, as long as they don't react with each other, which is the case of air. This means that the pressure you feel is the sum of the pressure of nitrogen, oxygen, argon, and the tiny carbon dioxide. This is now a physical law and is surprisingly called Dalton's law. The conclusion is, the Gadget is a better alternative than leaving your bottle or can open. They will offer the same result as a regular cap, but they will not prevent your soda from going flat because they only introduce air, not CO2, which is the gas needed to reach equilibrium. But if you want this cool pop, you can buy them.
One fact is that the CO2 used in beverages has to be a special one called Beverage grade CO2. It's special because it is 99.9% pure and is free of other gases and contaminants. It's located in the middle of the purity chart. There are even more pure CO2, but they have other uses.
The third one is the soda lock type devices, which is a spout that you screw at the top of the bottle. And in order to allow the release of the soda, you should squeeze the bottle. This technically does not allow air to enter the bottle and, theoretically, does not allow the CO2 to escape. This is what the manufacturer claims. Sounds logical at first glance, but that's in an ideal world. Unfortunately, this device is not for sale, at least not in my region. So I basically found this device that will help us to understand the principle. Now let's go through the features step by step. A. Does not let air in. As we already know, it's not the air that enters the bottle that makes it flat, it's the lack of CO2. As you can see, if I don't let air in, eventually the liquid stays in the bottle because of the vacuum. If I keep squeezing, eventually air will come in to break the vacuum and let more soda out. I also did the test with soda and it was the same result. Also in their ad, they had to remove the device eventually because of this reason. B. Will keep the CO2 in the bottle. Even if you have perfectly kept the CO2 in the bottle as you serve, the empty space increases, and now you need more CO2 to fill this new larger empty space and increase the pressure to reach equilibrium. In their case, the bottle stays squeezed, which is not my case. Well, I made a test and squeezed the bottle and put it in the fridge with a classic cap to avoid gas escape. After 1 day, it returned to the original shape because the CO2 keeps escaping from the soda and inflating the bottle again. Of course, this will happen if there is enough CO2 in the remaining soda. The same thing will happen to the bottles they use in the commercial. The product may have other benefits and uses, but remember that we are only testing the carbonation retention ability. I can only give you partial conclusions as I never had the product. Probably doesn't prevent fizz loss since the soda will continue to release the CO2 to reach equilibrium as the empty space in the PET expandable bottle increases. Of course, since it has a cap, probably is better than just leaving the soda without a cap.
During my research, I found that each brand dissolves a different amount of gas in their products. For example, Sprite has half the carbonation level of Pepsi and Coca-Cola. Also, the commercial soda available with the highest carbonation level I found is this one by Pepsi, but it's only available in Japan. According to studies, the maximum carbonation level recommended is 8. Increasing this value may cause an unpleasant taste and a strong burning sensation in the mouth and throat.
The fourth position is one of those vertical social media tricks. I'm talking about squeeze the bottle. I included it because we already saw a hint of what happens in the previous case. As we saw, the gas keeps escaping from the soda and even inflates the bottle again. Let's explain a little more. This is called negative pressure. The bottle tried to return to its original shape. This creates even lower pressure inside of the bottle and forces even more the release of CO2 from the soda. Once that negative pressure disappears, the bottle has its original shape. The process to reach the equilibrium starts, extracting more CO2 as we already saw. Anyway, just in case you're watching the side-by-side comparison, for some reason the second serving looks like it has more gas, but it's probably because of how I pour it. If you still doubt about it, ask yourself from where comes the CO2 that inflates and squeeze closed bottle again. When you buy the soda, it's totally pressurized and in equilibrium. It will not stretch anymore. So it's the combination of the bottle container and the CO2 release which increases the pressure. The conclusion on this vertical social media trick is no, it doesn't work, no matter how many followers you have.
The level of carbonation has no important effect or risk to your health. However, the ingredients in the sodas and similar drinks you choose do. For example, the excess of sugar and other chemicals present in sodas and similar beverages. And yes, that includes those labeled as sugar-free, which contains artificial sweeteners and other sugar substitutes. I will leave in the descriptions the studies I read to make these claims, but you can check them out after you finish this video. I'm watching you.
I have included this fifth item not to review it, but to clarify its purpose. I'm talking about the soda dispensers. Sometimes the online stores that sells them spice up the features by saying that it helps to keep the fizz, but that is not its purpose. It's meant to be used at parties to avoid dropping the bottles, never to keep the gas. Some models even come with instructions that you have to make or not a small hole in the bottom to use it. We saw what happens if you don't do it. And remember the empty space that increases as you serve? It appears here too. Equilibrium. Conclusion? Was never designed to keep the fizz in your soda, only to serve it. Remember, I'm only reviewing the use of the product in soda, but I suggest you watch some reviews in YouTube before buy one, or if you like foamy soda.
Even when this gadget was available for purchase, to be honest, I didn't even try. At this point in the video, you and I both know it's not going to keep the fizz. I decided to clarify it based on the bad reviews I saw online because of this confusion. At this point, I have reviewed all the classic methods, since the rest are similar or variations of the ones I have presented. Technically, the video should end here without successfully keeping the fizz in our sodas, but I decided to keep investigating to see if it's even possible. Which one is the ultimate solution, even if it means that we technically are not going to be just keeping the fizz. After reviewing 5 products, we basically know what we need. 1. Keep the soda under pressure with CO2 to achieve equilibrium. 2. Prevent the CO2 dissolved in the soda from ending up in the empty space of the bottle or can. It seems that the only real solution is to introduce CO2 from an external source, because every time we open the bottle, some gas escapes.
The Carbonators. These are devices that dissolve gas in water to make sparkling water. They use an external CO2 cylinder to infuse it directly into the liquid. They also use a seal connection bottle that helps to increase the pressure, what we have seen so far we need. But can these devices really make my soda fizzy again? Let's have a look. Step 1. I searched the instructions for these machines. I chose 5 different brands, and 4 of them had this sentence: only carbonates plain water. You cannot use them to carbonate your old soda. This would be a misuse of the device and could put yourself at risk. It only takes a 1-minute search on any social media to see devices being damaged on video because they were trying to recarbonate their soda, beer, or any other bubbly beverage. However, this one, according to the manufacturer, could be used with soda, among other beverages.
As an alternative, all the Carbonators allows you to create your own soda from zero. You carbonate the water and then add one of the many flavors that are available. To be honest, I had no idea that this subculture of home carbonation people even existed.
Now take your wallet because all the Carbonators have in common this cost. Buy the machine, buy the CO2 cylinders, and every 2 or 3 years, buy a new pressure bottle.
Let's comment on some aspects about these Carbonators. Again, this video is not sponsored or endorsed by any brand. It is difficult to reproduce the conditions of pressure and temperature they had at the factory with those huge vessels to carbonate soda. So my prediction is probably you're never gonna get the same carbonation level that it originally had. As we already saw in the carbonation chart, sparkling waters have less fizz than our regular sodas, and these Carbonators are made to make sparkling water. So the result, no matter what, will have less CO2 than your original soda. Finally, in terms of safety, you can't block the carbonator nozzle in any way. The gas is expelled at high pressure. That's why their custom bottles have expiration dates, because any damage or crack could break them or even explode while you're using it. Here we're going to have more an opinion than a conclusion because I don't have the product. There are many models available, and there's even 2 possible solutions: recarbonate or create your own soda. In general, this device works. I don't know which one is durable or not, or which one is the best. In my case, it's like an overkill to have this device in my kitchen just to recarbonate some soda. Also, I'm not a fan of sparkling water and barely drink sodas in general, so would be a no. Now, it's up to you to choose if it adapts to your lifestyle or not, but calm down, that the video is not over yet.
And finally, the last one. I'm talking about the CO2 handheld dispenser. And just like the Carbonators, they introduce CO2 into the liquids using an external gas source right into your PET bottle. You put on the special cap, connect your selected CO2 source to the device, insert the tip into the cap, and press the device button to start releasing CO2. This device is used in the production of artisanal beverages, even wines or beers. I tried some sites, but the product was not available, and some other sites, well, I prefer to stay away from PayPal. Also, I feel that this product is not widely available and it aims a niche. Regarding the price, it's not expensive. The bottle is the same as your soda, and the cost of the CO2 depends on the type of cylinder you buy.
About the limitations, this is not an industrial container, so probably have the same limitations we saw for the Carbonators. Now, the only opinions I have might be, this device is less structured than the Carbonators, So you gotta be more careful with the connections and the correct storage of the CO2 sources. The amount of CO2 introduced in the bottle is only limited by you. In theory, this could allow higher carbonation levels, but also could represent a higher risk of misuse. With these two last methods, we found the final answer to how to make your soda fizzy again. I can't say which one is better or for how long the carbonation lasts because I don't have them. However, from what I investigated, I found that the dispensers claim they are better because you can use any CO2 food-grade cylinder. The Carbonators have their own proprietary cylinders. The Carbonator says that they are practical and safer than the other minimalistic device. Hypothetically, if I had to choose between these two last methods, I'll go with the CO2 dispenser. It's small and practical. However, I feel that both methods are somehow complex. You know, the CO2 cylinder, the temperature, the device safety, maintenance, etc. Also, the real effective process requires that the soda be kept under pressure for a few hours at low temperature. This is the first answer. Let's go to the second one. If you just want to keep the fizz in your soda as long as possible without the use of complicated equipment, keep your soda as cold as possible, serve quickly, and chill again. A colder soda will release less CO2. And in the case of the cans, you can use one of the caps I tested. They will offer the same effervescence loss that PET bottle caps offer. That's it. Those are the answers I was looking for. Let me clarify a little bit that even if PET bottles are sealed, they will lose some CO2. In fact, if they are stored in bad conditions, high temperature, gas heat, etc., they will lose around 15% of their carbon dioxide in around 3 months. According to what I have found, the best containers for keeping the fizz in our sodas straight from the factory are the cans, the second, the glass bottles, and the third, the PET bottles. The advantages of glass bottles is that they don't react or interact with the soda. Cans don't react or interact because they have a protecting coating inside to prevent corrosion. The glass bottles are in second place because they lose some gas through the cap interface at the top, while the PET bottle loses gas mostly through its surface, where the red color means more CO2 loss, going through yellow, green to blue, which have the lowest CO2 loss. The pass of the gas through the walls of the material containing the food or beverage is called permeability. And thanks to the development of something called designer coating, current PET bottles have reduced permeability, allowing to improve how water vapor, CO2, and other gases permeate in the bottles, cans, and food packaging in general. These developments have allowed the CO2 to be retained in PET bottles longer than when they were introduced in the 70s. The development still continues with 3 new technologies that will help to protect packages of food and beverages, like
the Nano-Bricks. These are polymer clay nanocomposite thin transparent films that protect the plastic from corrosion and reduce permeability. Right now they are being used with great success to protect bricks and metals exposed to the elements. For bottles, as far as I know, it's not yet used, but there are many papers on it. The second is diamond-like carbon. This is a coating film made of carbon atoms with the atomic structure of the diamond and graphite. Unlike the Nano-Bricks, it is not transparent, and it seems to be used more in between 2 materials. It provides corrosion protection, reduces friction and permeability, Right now it's being used in tools and materials to increase their resistance, and there is a development ready to be used in engines that could save billions in fuels by reducing friction in engine parts to almost zero. Link in the description. And finally, CVD, chemical vapor deposition coatings, in which a usually solid material is turned into vapor. Then this vapor is deposited over the desired surface. This is done in chambers at high pressure or under vacuum. This creates a high-quality solid thin films and coatings. This is the most complex and difficult to implement because of the use of these chambers, currently used in the semiconductor industry.
Thanks for getting this far. I hope you learned as much as I did just by answering one simple question. Unfortunately, I had to leave out really interesting information just to keep the focus of the video. If you enjoyed this video, you can help by giving a like to help promote this work. I'm looking to grow my channel. We finally surpassed 1,000 subscribers, and I want to thank you all for that. My videos in general takes months to complete, from research, recording, editing, animation, etc. I'm trying to provide the best videos I can produce. Subscribe if you want to support me even more. I am Rash, and I'll see you on another remental video. According to what I have found, carbonatación natural por at reviews I saw soda with the highest carbonation level I found. Gol.